Thank you for being here and lending us your eyes and your ears. Looking forward to an interesting hour together. So hopping into the talk, this talk is called QA Bots for Everyone. And obviously, if you don't know modl.ai already, I'll present us in just a second. What we do at modl.ai is basically we do our best to enable as many people in the games industry as we can to have access to AI bots for QA purposes. And that can mean a bunch of different things. I'll give some examples of that in this talk. I'll talk about why we see a need for this, but we'll also give you some concrete examples of some wins and some benefits that we've seen out there in the market and working with our customers in terms of automating QA with AI bots. We'll give you some numbers based on what we've seen as well. And I think one message, if you want to take anything away, it's just like one or a couple of sentences from this talk. We think that just about any game production can have a benefit from integrating game playing bots into their testing processes. And we think that's something you can obviously work with someone like modl.ai to gain that. That's something that we love, of course. But we also think it's a greater movement that if we're successful in doing this across the games industry, it can be of benefit to the whole industry as writ large. So that's also why we invest in communicating about these things from modl.ai. It's both to talk about what we do, but we'd also love to see other companies and other game productions rolling out solutions for this because we think there are a lot of benefits to be had. So here we go. First of all, just a little bit about me. I'm Christoffer. I'm one of the people who started modl.ai. Back in 2018, we got started, and we really started scaling the team in 2019. A little bit about myself. I come to game design and development originally by way of psychology and psychometrics, with an emphasis on statistics. That's a known danger that you might slip into AI if you work in these things. But always really wanted to work in game development. So after I'd done my starting work in psychology, I kind of like took the consequence and I became a full-time game developer. So I've been in the games industry professionally since 2008, and I also did a little detour back around university and specialized in AI and machine learning for games, which is something that I've been working in since 2011. In modl.ai, we work to bring these two things together. And if you want to think of us as again, sort of like a one line that describes who we are at modl.ai, we're all about finding practical benefits for game developers using AI and machine learning, addressing a lot of things that we've seen ourselves. Other things that I used to do, I used to run some education in game science and design. I also used to run an indie studio where we shipped across many different platforms and devices: Xbox, PlayStation, Switch, mobile phones, Sifio cubes, and on one memorable occasion, also a toaster, though that wasn't really a scalable product. Most of the interesting work that happens in modl.ai isn't done by me because I'm just one person, and also I'm lucky enough and fortunate to have a team that's much smarter than me. We have 35 people in modl, and if you look at the team here that you'll get in touch with if you talk to us, you'll be talking to people who shipped a bunch of games, who worked in a very specialized capacity on AI and machine learning for games, or people who did both. You'll find most of us in the Central European time zone, so up here in Copenhagen, but we also have some folks in the US, we have some folks in the UK, and so like dotted around Europe. But we have a physical location here in Copenhagen, Denmark. And should you ever find yourself around Copenhagen Central Station, then definitely give us a shout because we love to have visitors in our offices and talk about games and AI. modl.ai is backed by a range of different investors. Our three leading ones are Griffin Gaming Partners, one of the premier funds in game investing, M12, which is Microsoft's venture fund, and Rendered VC, which is a specialized gaming fund as well. So thank you to our backers and investors out there as well. So that's a little bit of an introduction of who I am and the wonderful people that have decided to work at modl.ai. And so going back to the mission, or kind of like the message that I wanted to bring during this talk that I mentioned early on, I think one takeaway, or the one sort of like message that we're trying to promote in modl.ai is that if you look at the game industry as a whole, we think that we are in many ways testing our games both too much and too little. And that has interesting consequences for ourselves and our players. It means that we are, for the vast majority, I know some of you out there are probably doing it in automated ways already, but for the vast majority of us, there are obvious benefits that can be had through automation that we're not grasping right now. And if we enable ourselves to do that, we'd be able to have a much better process, a much better development experience as teams. We would hopefully be able to de-risk our game productions, ship products that we are happier with, and have more time to work on the all overarching part that probably motivates everyone in game development, which is like expressing our creativity through the experiences and the technical solutions that we put together in games. Because if you look at the industry of the game, the state of the games industry right now, I think our current production processes in games are just straining up against some of the challenges that come with building bigger games, building them faster, updating them more frequently than ever, and working predominantly under a live operations paradigm. And you can see that in a range of different ways. But one statistic that we got recently from some research, some pretty comprehensive research work that was done on the industry, was that if you go ahead and ask game teams, they'll tell you that 61% of games ship with known game-breaking bugs. And I think the developers that ship those games would probably have loved to fix them or have a process that allowed them to fix those bugs before they ship them. But given constraints and given the way the world works, they had to ship them anyway, and that's just the way that it goes. So that's kind of like the overarching opportunity out there. I don't think anyone really wants to ship a game with a known game-breaking bug, but it's just something that reality, in terms of size, in terms of speed, in terms of scale, means that that's something that we'll all find ourselves in a situation where we have to, if not do it, then at least contemplate it at one point. And there are many different ways that you can address this, and I'm certainly not going to say that AI is the wholesale, one-off solution to all of this. But I do think that there's a lot of potential in addressing this with automation with QA bots. And one of the arguments that I'm going to make in this talk is that no matter how small or big your game is, there's probably some level of utility for artificially intelligent bots interacting with that game. And that could be addressing your gameplay, it could be addressing your QA systems, it could be addressing basic things like does the game start or not, if you need a little bit of like intelligent interaction with it. But those are the things that I'm going to give some sort of like what I would call practical and pragmatic examples with in terms of like how that can work. But before we kind of like dive into the tech and the product and how you would do that sort of like practically, another point that I always like to make is that once you start integrating automation into your development process, number one is of course that you need the systems to do it. But before you even start contemplating that, you have to think this as a consequence of process change. So in many ways, like automating any of your QA functions starts with engaging with the people who are going to be using this before the tech even becomes relevant. And what do I mean by that? Well, I'm going to dive into that in this talk, and I'm going to hopefully we'll have a conversation about it, and we'll get your perspectives as well. But the one thing that we definitely one thing I can sort of like anchor that in is that imagine if you have something that plays your game automatically for you to help you understand how your game is working, to help you understand where the bugs might be. Well, one notion is to have that just running in a single instance or running on your developer machine. That can be really welcome and useful. But what actually happens when we start scaling this process? What if we have, not one bot playing your game at one time, but what if we have 12? What if we have, 20, 25, or 100 of these, operating your game at the same time? And that's specifically what you're seeing here for a title that we worked on. This is a title built out by a team of around 40 to 50 people, I believe. And for this particular title, well, we ended up in a process where we had our bots playing their game every week in order to enable them to be more efficient in their processes and spend their human time where it really mattered. So think of like AI bots in this way when you're using for the QA purpose, but if you combine them with scalable infrastructure, they're perhaps less a replacement for somebody interacting with the game and more an accelerant for the people who would have been playing the game in order to generate data about it anyway. That also means that one side of this is that if you start scaling these processes with AI bots, you start having a lot of data available from your game. Suddenly, you might have 100 of these running at the same time, right? And you have all this information and data coming in around your game. So the second process change that you have to think about when you're trying to bring this out to folks is, well, how are people going to consume this? And this is just, an example of like our take on this in modl.ai. That's what I'm showing you here. This is a web application that we use and our customers use to make sense of the data that come out of automatic testing. What it basically allows you to do is to upload your game up onto this platform, get a copy of the game build. You have a bunch of game builds available right here. Once you have these up, you can, we're uploading a new one here. Okay, we already did. Once you have them up here, you can then start a test and have these bots like interacting with your game. And if you have that capability, how do you actually make sure that the information that you garner from all of these automatic runs become of value to your internal team? How do you make this a decision-making asset rather than a chore that you have to step through? Well, what we've been trying to do in modl.ai is that we take the output of all these test runs and we put them together in kind of like a cockpit that you're seeing here. And the intended user for this kind of like information could be a developer, of course, but predominantly like would be a QA specialist is kind of like what we're imagining. And we're trying to sort of like enable them to have, an overview where they can see everything that happened in a particular game run, something that quickly brings their attention to where the points of interest happened, and something that allows them to see specifically what happened inside of the game, where it happened, and at what time. So that's at least our take on it. That in order to facilitate the process change that comes with automation and having AIs that play games, you need a couple of things. You need both the capability to control the game. You need the ability to scale like that game being run. It can be helpful, but you're not really realizing the full potential if you only run it on one computer. And you need to think about the people who are actually consuming the information. How do you make sure that people aren't just overwhelmed by a tsunami of data whenever they run the game? Those are kind of like three major components that we tend to think about when we drive automation projects with our customers, and something that I would recommend that you think about as well, if this is something that you're integrating into your own game development pipeline. Because it really starts with the people who will end up using this and engaging with the particular workflows and the specific problems and challenges that they're seeing in their work. Because at the end of the day, this is about scaling the scarce human resources, time, and attention that you already have. One sort of like model that might be useful for thinking about this is sort of like concept of the testing pyramid. I'm sure we have some experts on that here in the audience, but kind of like just giving a super brief overview. If you think about testing existing, this is very sort of like at the gross and coarse level, of course. But if you think about when you're testing your game, sitting at different levels of complexity, depending on how atomically you're testing different parts of your game at different times, you might think about it as consisting of unit testing, which is something that goes as close to the atomic part of the game as possible. Integration testing, where you see sort of like how these different things actually work together, if you're seeing expected consequences of things actually operating in the game, and then end-to-end testing, where you're interacting with the full application. And the argument that we make, I guess, in modl.ai is actually that historically the games industry has been spending a lot of their human time here, which makes a lot of sense, because this is one of the places in game testing where you can't really anticipate the emergence, and you might not be able to really understand if the game works as you intended unless you actually operate it and interact with it. So you can kind of like imagine that there are three questions here where the latter bottom part here, is kind of like, does the game run at all? Does it work at all? And the upper part here contains that as well, but it also, it has the nebulous question, does it work as intended? And I think, we have good practices for driving things like unit testing in the games industry. That's starting to be, that is well understood, and that's something that is rolled out in production, of course. Integration testing as well. But end-to-end testing has sort of like remained, that part of the testing problem that was really hard to address, specifically because it is so complex and so hard to do. Like at the end of the day, we're trying to assess if a human experience is working the way that we wanted it to. We're trying to maybe break it, but also to see if everything is in its intended location. And the reason that we haven't seen a lot of automation happen here is simply that it's so darn difficult to do without with anything else but a human level of intelligence. But still, if you look in that part of the testing, sort of like stack or the pyramid here, there are parts of end-to-end testing that can be repetitive, can be monotonous, is something that needs to be repeated every time you play the game, every time you want to test the game. So in many ways, there's still a lot of work going on up here at the top of the testing pyramid. But if we just had the right tools for it, or if we implemented the right processes for it, we could probably automate it. So you wouldn't need to have your human intelligence focus on that and doing that over and over again. But you could put greater emphasis on this question of like, is the intent right? Is the player having the experience that I want them to have? And I think in recent years, with developments in gameplay and AI and different kind of like AI tools and utilities, that's actually coming, within reach in terms of how we can operate our games automatically. And so that's what I'm going to show you a couple of like pragmatics example around here. But before we head into that, I guess the fundamental question that you might want to ask is, why is this worth solving at all? Is this like a real problem, or is this actually, have we actually figured it out as an industry? Like, are all the things that we're kind of like premising and saying here as a company that does this kind of work, is it really useful, or is it needed out there? So late last year, a very interesting piece of research was released by Rendered BC and the Griffin Gaming Partners. I can say we weren't involved in building this, but obviously the results are of great interest to us at modl.ai. And what they went ahead and did was that they surveyed 537 different studios across the world. And they were also balanced across other parameters, like things like the studio size, and the individual participants were also stratified and balanced in terms of like what kind of like discipline they had in the industry, what kind of work they do. And I'm only taking out a few of the results from the report here, but because it's pretty comprehensive. But if you haven't seen it, I'd recommend grabbing it and having a look at it. I found it very interesting. But basically, like the core thing that people keep coming back to in terms of the overarching concerns for studios is that game development is expensive, and it's getting more expensive over time. So 77% of studios will tell you that costs are rising. 65% of studios, so the majority of the industry, are working on live service games, so they can kind of like anticipate having to update these continuously and going forward. And 88% of the respondents in this survey told them that just in general, across disciplines and everything, people would love to have more tools to help with addressing this issue. And I think it all comes back to this phenomenon that I talked about when we started the webinar, and that games are getting bigger in terms of scale, or they're getting faster in terms of release cycles, they're getting more varied, or you start incorporating things like user-generated content that, frankly, just give you unexpected things happening inside of your game once you have all your players helping out with building the experience as well. And one of the things you can sort of like double click on there is also that, no matter what kind of like dimension of scale we talk about, if it's like the game size or the speed or like all these different things, what tends to happen is that when you're scaling up your process in one direction or the other, more people will get involved, more things will happen faster, and you start having complexity in the game production. And that's certainly something that has been reflected in the answers that people gave to the survey. And you can really see that the place where all of these different sort of like contributions from a multidisciplinary game development team, they come together, is the people who see it all are the QA team, right? That's where it all ends up at the end of the day. And especially as you go into live operations and live service and you keep building your game over and over again, that's a process that never ends. So the numbers on the left-hand side, that's actually our own internal estimation in modl.ai based on what we've seen in the industry and what we've talked to customers or prospective or potential customers about. But it seems that mature, successful live operations title is something that you can expect to see running for years and years. It has a steady player base and everything. Well, they will probably be investing between 1.5% and 3.5% of their revenue, either monthly or yearly, into just maintaining and testing and keeping that thing running from the QA side of things. And in spite of that, most of them will still say that they don't have enough resources to do it. So that means that the industry is kind of like, at least from our perspective, in a position where it's not necessarily about doing less QA, it's about doing more QA with the resources that you already have. And you can see it in the survey numbers as well, where you say 61% of the respondents think that they'll be spending more on QA going forward. If you ask for people who actually do the testing, more than half of them would like to have better tools. And 70% of them have specific pains that they face every day because they just don't have the tooling that we're looking for. And that's where we think that AI bots, as part of sort of like an automation flow, that could really address a concrete pain in the industry, maybe an underserved part of the industry as well, that we just haven't been able to, partially because we didn't have the technology, partially because we didn't have the process change. And the overarching vision of integrating this is, well, we have sort of like two things that we think that the industry would really benefit from gaining from this. One is that if you start automating parts of your testing cycle and having that, happen automatically when nobody's looking at it, maybe when nobody's at work or when somebody's doing something else, you can really start reducing this part of the loop here that goes from development to building to maybe to testing. This loop here that goes on and on every time you do a game build. If you can reduce the time it takes for you to do the testing side of things, if you can be faster at finding the pertinent and relevant things that need to be addressed, you can actually improve the velocity or the speed of this whole cycle. And that's one of the things that we're really bullish about in modl.ai, is that if you give better tools to the testing part of your organization, you can probably see that come back across your whole company, across your whole game production, and see benefits come out of that, for everyone on the team. So an investment over the testing side of things can probably allow you to reap benefits across your whole development cycle. The other part that we're bullish about, the other thing that we think that this can do for you, is that it can help you reclaim human time. And we actually think that can be a guiding principle when you're thinking about different kinds of integrations, different kinds of things that you'd like to build into your game production process. When you're thinking about what should I be automating, the principles that we at least follow for choosing automation targets with AI is what is most time consuming for human developers out there, what might be best addressable by artificial intelligence, what's a good fit for the technology that we have at the moment, what is most generalizable. So that's specifically for us because we're a tools and infrastructure company, right? But what would go across different productions? But if you have multiple titles and you want to roll something like this on your own, that might be useful. What has the lowest maintenance effort? Because you don't want to be trading, testing time for integration maintenance time on the other side. And what is most scalable? What can you actually do, at scale with this? And if you look at sort of like the different things that people are looking for in the survey that I mentioned before, well, you see that where are people spending most of their time and most of their effort in terms of game testing on their game development projects? Well, you see functional testing, that's a big one. Combinatorial testing, when you have really wide-ranging, different ways of combining elements in your game. Play testing, so sort of like the ultimate end-to-end test that we were talking about, and then performance testing. All of these are like high scoring categories here, and it only starts dropping off once you start stepping down through things like regression testing, AS validation, still pretty time-consuming, smoke testing, unit testing, and collision testing at the bottom here. So if you had to sort of like build a target list of what do I want to address with a good AI automation solution, you could probably just like follow this list in order to see which of these can we address with the tech that we have. So we have 4 different answers to this, 4 different concrete things that we've done in the model that I'll show you in just a second. And as we were building these out, we were following these principles ourselves, or like kind of like our version of these principles that we follow internally, is we say whenever we build out an AI-driven testing functionality, we should try to minimize the integration effort. We should be making sure that we're solving the most time-consuming thing first, because it's all about freeing up that human time that we talked about. And in any way that we can, we should be scaling sort of like the human component here. And so we've developed and deployed 4 different kinds of automated AI that tries to follow these principles. And it goes from sort of what we call exploratory testing to functional UI testing to balance testing to play testing. And as you move down through sort of like this, these steps here from 1 to 4, more effort is typically involved with each of them, either on the developer side or on our side if we're helping out with getting this into the game production, but also the amount of time you save and the benefit tends to go up and you invest more in it. So at least for now, we venture that there's no free lunch in using AI for your automation needs. But if you invest more, you also tend to gain more in terms of what your team and production get back over this. So if we start with exploratory testing, which is kind of like the simplest thing that we have, but also the easiest thing to get going with, I'll show you a couple examples of that right here. This is what it looks like when you're configuring our tool in Unity. You can get going with that with as little as 5 to 6 different code hooks. But once you have this set up, what you get is I wouldn't call it simple, but not necessarily a human-like AI that's capable of operating and interacting with the game with no prior training, with no prior data, and that adapts on the fly to new content. If you change your level, or if you somehow change the makeup or the setup of your game, as long as the fundamental sort of like ways that you control the player character don't change, and the sort of like fundamental notion of how you understand where the player character is, this is what you'd be writing your code hooks for. As long as those two things don't change, you're actually able to take this kind of like approach and just have it run in the game to provide you some basic coverage of every part of your level, anything that's interactable with or responds to the player. So you don't get something that plays the game the way that a human player would, but you do get something that can sweep through your content over time. And the way that we've implemented it, we're using runtime search with some specific strategies for understanding where we've been and learning how to go to the next place in the game. If you take an approach like that, you'll actually be able to get a guarantee that if you run it long enough, the bot will go everywhere, but it can't go inside of this game scene. So we think this is a great approach for things like basic smoke testing, checking the geometry, making sure that the game runs, and also getting pretty comprehensive performance testing across different parts of the game scene. And as I mentioned before, this is not something that takes a lot of time to set up, so it kind of like scores well on that kind of like investment versus benefit side of things. You can also take this over and use it for things like functional QA testing. That's something that we've done with a couple of games out there. We did it together with Die Gute Fabrik for a game that they built that was wholly GUI-based. It's a narrative game, so everything in that game is a GUI. And what we did together with Die Gute Fabrik was that we set it up much with the code hooks that I showed you before for the 3D game. But now the AI is not relating itself to like some sort of like geometric 3D space. Now it's just relating itself to like what are the options available in this GUI. And so what you're seeing here is the same algorithm that is moving through different parts of the user interface, and then is leveraging the safe game system to jump back in time and try a new path every time that it goes through. So you can kind of like imagine that you put this game on the server, and then the bot is running the game, and it'll sweep through the storyline in one way, and then it'll jump back in time using the safe game system, and then sweep through it again. And over time, you kind of like get coverage through all these different parts of the narrative as you're moving through it. But no specific scripting or logic is necessary to allow it to navigate it, because it's just sweeping through all of this until it's covered everything. And what this meant for Die Gute Fabrik was that they were able to ship their game really just with one internal QA person. As they were scaling up the team and building out a product, a game where you had more than 10 writers contributing to this, and a lot of the things that the writers were contributing was also things like logic that would decide like where do I go in the storyline and things like that. But concretely, what they would do is that every week they'd set this up and run. Their QA person would manage it, and then that would give him an overview of what storylines worked, what storylines didn't work, which did we need to look into, dead ends, things like that. So a comprehensive overview like of what parts of this works and doesn't work. So stepping up through sort of like the approaches and the different things that you can do with game playing bots. The next thing that we've seen work really well and bring back time to game developers is balance testing. This is something that we've seen a lot of interest for in the casual games part of the games industry. Basically understanding if your difficulty levels are set right, and understanding like how different outcomes are across different pieces of content. We've done that for a few match-3 titles over the years. And what we do there is that we ask the game developer to invest a little more into integration, because we ask them to start sending us data around how their actual players are interacting with the game, either internally on their QA team or externally if the game is live. But once you start having data like that, you can use different AI methods. In modl.ai, we lean a lot on imitation learning to take that data and then train a bot to actually play the game like the human players do. And that's what you're seeing an example of here. This is a system that we deployed. This one specifically with Good Game Studios in Germany for one of their match-3 productions. And what they got out of this was basically a way of submitting a level to the system, then having the bots run through it for as many times as we wanted to. and then get gameplay statistics in terms of like, is the level too easy? Is it too hard? How many moves did it take to complete this? And the fundamental benefit of this, like step one, is just that normally, at least it's my understanding, is that the industry standard is we'll do that 10 to 15 times per game. So that's just a lot of per level, sorry. So that's a lot of game designer time that goes into that, or tester time when you've built a level and you want to understand like how the dynamics are. Well, with this kind of system, you can get that immediately and you can get back to creating the level. So it sort of like tightens that creative loop. And specifically what we've seen with this kind of like balance augmentation using the systems, well, we've seen that you can get up to like 16 times faster in terms of getting levels into your game better. And one thing is like how many levels can we put out, but certainly it also frees up the game design team to think more about the experience that they want the player to have, and less about sort of like playing through things and then putting numbers in a spreadsheet. Third approach, or fourth approach, sorry, that we've taken is then sort of like wholesale play testing. You'll remember that was one of the time-consuming categories in the survey. It's one of the real pain points for AI testers out there. And one of the things we've actually often run into is that if people are building a multiplayer game, it can be really time-consuming to test it because you have to pull out like a bunch of people from your studio in order to make that happen. In certain instances, you might even be like, imagine we've talked to folks who are building, 64-player games, but they actually are less than 64 people in the studio. So it becomes hard for a single, person to even, there's just like no way that you test the whole experience without getting external help. So what can you do with that? How can you address it? Well, one of the things that we've seen work is that, again, if you invest a little extra into the integration such that you can collect data from the game, and you can observe again what your internal teams are doing or what your external teams are doing. Once you have access to that like data stream of actual human behavior in the game, you can, again, here we're using imitation learning, you can lean on that to build a game playing agent that starts copying specifically what your human players did as they were interacting in the game. So of course, this is kind of like less of a directed tester. You'd have a harder time giving this bot here like a test case and say, test exactly for this. But what you do get is something that can comprehensively interact with your game experience. It can be very helpful to the game design team or other parts of the team in just understanding how does the game work. When multiple people are playing in it, what are the dynamics? Or you could use it for things like load testing and other things like that, where you need to have a number of clients connecting to the game and interacting with it in order to really understand how your title is working. Kind of behavior that you're seeing here is from a demonstrator project that we did together with one of our partner studios and customers. And one of the things you'll notice here is that you actually capture, because we're basing this off what the actual human players did inside of the game, you will see things like, camping behavior. There's one up on the right there, it's waiting a little bit. They will hide inside of smoke grenades. They will, they obviously know how to defuse. There's a little bomb here that you have to place and or defuse it depending on what side you're on. But they'll also do weird things like throw grenades up into the air whenever they win, which is also behavior that's exhibited by the people who contributed data for this data set. To get the kind of behavior that you're seeing here, for this particular project, we collected 40 hours of data of humans playing the game. So if you have an internal or external QA team, it's not a ton to generate that amount of information. And you really get something that comes close to what the human players did without having to invest in script. There's no sort of like scripting or programming or behavior trees driving the behavior you're seeing here. It's all learned from what the players did. We have a little bit of tweaking on the outside so that the game designers can adjust a few small things to make it do what they want. You can also let these bots play on their own, and then you can take data from that and use that to make sense of your levels or your content sort of like at scale. I'm trying to be conscious of time. I know we're already 40 minutes in, but giving you a couple of other examples around this, just briefly. Other places where we've seen this work well, or where we've seen the benefits of taking this approach of learning from actual human players and the way that they interact with and play a game. You can see that right here. The blue character is me, that's not an AI, full disclaimer. The red one is. This is from another title called Fortune Fight that we worked on. And in this particular game, you have to construct your own weapons, and then you also have to figure out how to use them. And one of the things that stand out to me here is that the model construction, the weapon construction model that we used here seemed to have done well. The AI built like a reasonable weapon with a flamethrower and some melee, but it also knows how to use it, and it knows how to use it sort of like for control and strategically when it's playing against me. And again, all of that was learned from the player data. And one of the things that you can get from this is we like to say you can also capture game feel in a different manner. And you'd be able to build out if you were just scripting out a bot to play the game. Other things that we've seen this be successful for is that, well, at the point where you're actually collecting data across different kinds of players, if you're able to subdivide those in terms of maybe their skill level or the way that they play the game, you're also able to then train over different parts of the data set, and you start representing the actual players that you have in your game again, which can be useful both for testing and for design purposes. So that's something that we've seen benefits with some of the projects and the studios that we've worked on before. And sort of like trying to tie all this together, what we wanted to share with you today was just like these 4 different principles, 4 different kinds of bots for different challenges in game development. I hope we were able to show you how they work sort of like at the functional level. I hope you were able to imagine how they might enable a QA team if they had these players available on demand whenever they needed it. And the principles that we were following when we were coming up with these different implementation cases was always like minimize the integration effort and make sure that if you integrate more, you get greater value out of it. Make sure that you solve the most time-consuming, frequent, and general issues first, and make sure that we're always giving time back to your human teams, whether that is in the QA function, in the design function, in the programming function, any other function. It's all about winning back that human time. So things that we've seen, and we've sort of like tried to pull this together numerically across the different cases that we've worked on. The exploratory testing that we started out with low integration effort, but we've seen up to 25% reduction in your QA team's testing time, just because it takes away all these like basic questions about, does this work or not? Like, does this run? What are the performance statistics? Things like that. UI testing, we've definitely seen a massive output in very UI heavy games and applications. The specific numbers from the one that I showed earlier, that's 100% UI, of course. So that's the majority of that experience. Balance testing, we talked about how we were seeing that game designers get their content through much faster using this kind of tech. And play testing, these are just from our concrete studios, but suddenly one person can play test a multiplayer game on their own without calling on their whole team. That actually translates into a very significant reduction in terms of the whole team time that goes into this. So trying to pull this together, kind of like our philosophy in Model AI, we think that AI agents and getting bots into your games can give a lot of significant value across the production pipeline for many different disciplines. We think that the anchor people for making this happen is probably your QA testing team, both for understanding the results, but also for contributing the data that you bootstrap from, or that you start from, sorry, if you're interested in copying player behavior in there. And for us, it's all about having pragmatic solutions that are good enough to drive significant changes to teams, but also lightweight enough that you don't end up with a massive integration and maintenance overhead. The less you have of that, the better. So that's where we stand right now. These are the things that we've been putting out there over the last few years. But you might, of course, ask what's next. Here are a few of the things that we're working on in Model AI as the next step for us. We had a look at that survey again from the different developers, and we said, well, what are the next 2 things that we should probably address there? And one thing that we've been spending a good amount of time on this year is finding good solutions for asset validation. That seems to be a time-consuming thing for folks out there in the industry, understanding if all the things combine in the right way and if the assets have actually made it into the game in the right way. And then we're starting to take steps towards integration-less testing and see if we can provide value to people without them having to maintain any integration at all. So if we start from the first one, asset validation, here I think that as an industry, this is not something we have in production yet, but if you're very interested, please let us know, and maybe we could have a chat about it, because we are interested in working with some more studios and testing this out. But basically taking assets and using visual language models to understand. I think the first target here is kind of like, is there something wrong at all in this screenshot? And then the next target down the line could be specifically, what is it? We have a little cherry picking here, perhaps, but you'll see that if you can read the text down here, the description that you're getting out of this visual language model is actually pretty good in terms of what's the issue in this particular image. Can't show you any of the concrete things that we have right now, but here's some images that we also took from the internet, from known glitches and things like that. And again, really good performance here, where you can see not only does it identify that there is a bug, but it's also kind of like showing you, oh, it tells you, oh, for this particular gun here, it seems like somebody misplaced where the muzzle flash is, and somebody should probably have a look at that. And not 100% perfect yet, I would say. Over here, if you take this one, number 3 here, it'll tell you that the lamppost has fallen over. But it's good enough to tell you that something is at least wrong inside of this image. So maybe a good starting point for that. And then the second thing that we're looking into is, what would it mean to have the ability to play a game without integrating into it at all? We think things like computer vision, again, maybe coupled with large models for reasoning, has a lot of potential. Again, the way that we're going about it, we use player data for the same thing. So we always rely on garnering some actual player behavioral input. We find that accelerates the process quite a lot. But here's an example of a game that we worked on and tested this out on, where we never saw the source code. So for this particular game, we only had a game build. We collected what was happening on the screen. We collected like what inputs were being given, how the game was being played, and then we collected data from that and trained over that in order to play the game well. And you can see that it has the ability to react at a moment-to-moment basis. This is captured directly from the screen of a phone, so this is real time. This is how it was running, and you actually get something that's kind of like competitive with human players there. And would be good enough for addressing that playtesting question again. I think the only open question here is you do need some more player data. The data requirements go up a little bit if you start collecting it, just from the interactions, direct inputs of the screen, and obviously with things like reasoning, that thinking about longer term planning and things like that. That's a place where large, visual language models will also really drive a difference in the future. So 2 things that we're looking into and we find exciting about the future of this space. So we think that there's benefits across the whole production for this kind of like an approach. I hope we have time for some questions and some interacting as well. We think that QA and testing in the games industry has been underserved up until now because the problem is super hard. That's why you need people for it in the first place. And as you're building out pragmatic solutions, think about the people who will actually be using it and how it benefits them. One final plug before I turn off the screen show here. I just want to say this is very soon. So I hope there's still time to sign up. I haven't checked today, but if you're interested in this space, if you want to learn more about it, we organize a summer school every year. This year it is in Malta. And it's co-hosted by Keyword Studios. So go to school.gameaibook.org if you're interested in learning more about that. And thank you very much.